So in example 3 here, it looks like we have two similar right triangular prisms. And then we have four things we're supposed to do. Find the ratio of the perimeters of the bases, the ratio of the surface areas, the ratio of the volumes, and then find the volume of the larger prism. So what I have up here are our three main formulas. I've made kind of a formula bank, if you will. And so that we are going to need as you talk about similar and congruent solids. And keep in mind that area, so we'll do a little asterisk here, area also means surface area and surface area. Okay, so the ratio of the perimeters of the bases. So we know since the side-to-side ratio equals the perimeter to perimeter, I can pick any set of side-to-side, here I don't have quite enough room, equals perimeter to perimeter. So I know if I pick any set of matchy-matchy sides, they will reduce to the same ratio. 4 is to 10 reduces to the same thing as 6 is to 15. So all I have to do is the side-to-side ratio is 4 is to 10, or in other words 2/5, and so the perimeter ratio will also be 4 is to 10, or 2/5. So I'm going to erase all this since I don't have a ton of room, and say 2 is to 5, or if you want to say 2/5, that's the same thing. So, all right, now for the ratio of the surface areas, we're going to go to our second formula there. Let's see, maybe I can go over here to the side. This is for part B. So for this one, we're going to go to side squared is to side squared equals area is to area. And we said it's the same stinking thing whether you're talking about surface area or actual area. So our side-to-side ratio we already established is 4 to 10, is 2 to 5 in other words. And that should be equal to the ratio of the surface areas, right? Surface area, it's all different forms of area. So this will be 4 to 25. So we're going to say 4 to 25 or 4 to 25, like that, either one. Okay. All right, then for part C, the volume ratio, let's see if I can go a little bit further over. So for part C, we're going to use this third set of formula, this third version, that side cubed to side cubed equals volume to volume. So again, I don't have to actually find the volume of either one of these right triangular prisms. I don't even care what the actual volume is. It didn't ask me for the actual volume. It just asked me for the ratio of the volumes. So all I have to do is take those matchy-matchy sides, 4 to 10, or let's go ahead and reduce that to 2 is to 5 again. And I just cube it. And that's it. Because whatever those volumes actually are, if you were to actually find them and reduce them, you would get, it would reduce to the same thing as 8 to 125. So that is the answer here. I don't really have enough room to write another version, but we know that's the same thing as 8 over 125. All right, and then the last question, suppose that the volume of the smaller prism is 48. So this one is a volume of 48. And find the volume of the larger prism. So on this one, we actually are looking for the volume. But again, you don't have to do area of the base times height to find the actual volume. Although we have enough information, you could do it that way. The shortcut is, since we know the volume to volume ratio is 8 to 125, all I have to do is 48 to x and cross multiply to solve for x. That's a whole lot faster than actually having to find the volume. So 8 times x is 8x. 125 times 48 is 6,000. And so now I have an equation, and the only thing left that I need to do is divide by 8 in order to solve for x, the volume of the larger figure, in which case I get 750, and because it's volume, that would be inches cubed.